Good morning, everyone. So this week, what I want to talk about is using the robot. So some of you have gotten this Mbot Ranger robot kit, and you are planning to use it for your final project. And there's a bunch of work that's going to need to happen to go from having a physical robot and having a sort of minimal simulation of that physical robot to being able to string everything together into a control program and the necessary stuff around that to accomplish whatever you're trying to do for your project. Now, I know that some people are not planning to use the Mbot Ranger, and I'll spend some more time talking about using Gazebo at some point in the future. But this week I want to try to talk about sort of integrating with this physical robot kit, because I know that a bunch of people are using it. So if you're using the Mbot Ranger, there's a key complication in getting sort of non-trivial code to control the robot. And the key complication is that this is an Arduino. So that means this is based on a microcontroller board. And the microcontroller board has a slow processor, a slow embedded processor. I don't know exactly how fast it is, but not fast like a desktop or laptop computer. And sort of more immediately problematic, it has 8K of RAM, not megs of RAM, not gigs of RAM. It has 8K of RAM. It has 256K of program storage space. So it's possible to have a certain amount of code on there, but that code has to be careful about how much data it's storing. So if you're trying to do something like do robot navigation with an occupancy grid, that's not possible if the only computer in your story is the robot itself. And so that leaves us with some questions. How do we run sort of full-size programs? And there's three sort of coherent options here. Plan number one is don't. Just use the Arduino. And that's possible. You'll have to do, if you're going to set up a Gazebo simulation to work with that, you're going to have to do some shimming to make it so that the Arduino program can effectively run on your computer as part of the control program, but that's not actually terribly difficult. The Arduino code is just C++ code. You can compile it with a C++ compiler. All you need to do is make it so that the sort of Arduino interface stuff is replicated in your control program. Make it so that setting digital pins has the same effect as controlling that piece of hardware. And that's entirely possible. But it means that you're limited to your robot having relatively simple behavior. Not trivial behavior. You can do quite a bit in 8K and 256K of program space, but computer vision and occupancy grids and some of the other stuff that we've looked at just aren't possible. So if you want to get into a more complicated control program, the next option is run your main control program on a computer, and to do that, the best way to do that would be to hook the computer up with Bluetooth to your robot. Unfortunately, that is one of the things that I wanted to figure out how to do. I'm sure it's possible, but I haven't had the opportunity yet to put in the time to make it work. The sort of more straightforward way to do that would be to connect with Bluetooth serial, and it looks like the robot isn't quite talking normal Bluetooth serial, so I don't know how to do that, so that may not be possible. And so the next possibility is that we just have a physical wire connecting the robot to the computer. You're running your thing tethered. That's ugly. It would be great to avoid it if possible. It's worth spending some time trying to figure out how to get Bluetooth to work to avoid that wire. But if we end up having to do projects with wires because we're all constrained on time, that's okay. But if you can get Bluetooth to work, that's definitely a bonus point if you can share that Bluetooth demo code to do computer to robot communication with the rest of the class. Now, the final option is the one that I like the most. Run your main control program on a phone. So let me show you what I mean and why I think that's an especially useful option. So right here, I have a cable. And this cable goes USB-C, which is what a phone, sort of modern phones normally do, to USB-B, which is what we have on the robot. So if I go ahead and unplug my robot from my computer, which is where I had it plugged in, open up this cable. I haven't actually opened up this cable. We can plug one end of this cable into the robot. Let me show what we're doing here. So we're going to plug one end of this cable into the robot. Totally plugs in here. We can plug the other end of this cable into a phone. Here's a phone. We plug the USB end of the cable into the phone. And then we have a wired, phone connected to a robot. And we can do really neat things like find somewhere to mount this phone so that it has a forward-facing camera. Maybe the best way to do this is to disconnect the sonar sensor, which leaves me with an extra wire. But then I could run the phone like this. And the result here would be that I have a relatively chunky, powerful camera off the phone here, and the phone is a reasonably powerful computer. Now there's some mounting issues that makes that a little bit tricky, but that is the option that I think is most exciting for getting the robot to have a relatively powerful computer on board. It's actually slightly more elegant even than Bluetooth, because it means that the robot, the phone-robot combination, is self-contained. And this robot can clearly drive around with a phone on it. That's within its load capacity. In any case, in order to program a robot using a phone, that requires getting the phone programming API up and running, figuring out how to talk serial, because that's what we would be doing over the wire, is we'd be sending serial messages back and forth between, whatever we're hooking up to the robot and the robot. They communicate by USB serial. And so we have to figure out how to send and receive serial messages from the computer or the phone, and then we have to figure out how to accept those serial messages on the robot end. The thing that I want to talk about in this video is how to talk to the robot by serial. And of course, I'm going to do it the worst way, and that is with a computer connected by a wire, because I don't want to get into Android programming for this particular thing. I think if I pulled out a Linux phone, that just wouldn't help anybody, because I'm probably the only one who has a phone that's actually running desktop Linux. So we're going to use a wire connected to my computer. This one, it's a USB a USB-B end. The other end's a USB-A end plugged into my desktop. I'd show you better, but I think you probably understand what I'm talking about when I say USB-A. That's the flat one that goes into a desktop computer. So I'll plug this back into our robot. You can see it lights up because it's getting power from the computer. Maybe you can't see that it lights up. But now what I want to do is I want to go ahead and write a control program, or show you a control program, that we can run on the robot to make it do something. So first I'm going to start with this color loop example, which is actually one of the example programs that is provided in the libraries for the robot. Oh, before I get into this example, I want to go through a quick set of stuff, which is just the setup process. So here in the Gazebo, like cs5335 starter code Git repository, I have the setup.md file, which I've provided. And in here, there's some tips that I got just getting this demo code to work. If you're connecting via USB on Linux, you have to make sure that your permissions are correct. On Debian, that means setting up the dialog, setting up your user as a member of the dialog group. The same thing works on Ubuntu. If you're not on Debian or Ubuntu, you may have to do permission, some sort of permissions yourself. Worst case is you have to set up a udev rule that detects this particular USB device and then sets the permissions to something. I mean, if you're detecting this particular udev device, you can set permissions to 777 so everybody can do everything. Because I don't think that we have like some robot security hole with other users on your computer connecting to the robot. But in any case, you do have to set up this permissions thing, and this is the easy way to do it on Debian and Ubuntu. You're going to need an Arduino control tool, programming tool setup. The straightforward way to do that is use the standard Arduino IDE, which is a graphical editor with buttons that let you upload stuff. I kind of like typing in Vim or Emacs, so I'm using the Arduino command line interface, which provides command line tools to do Arduino things and then lets me write code in my preferred editor. You want the Mbot Libraries. If you go here, that'll explain how to do that. And then the sort of key trick here is that for this robot, the Mbot Ranger, the control board shows up as an Arduino Mega 2560. So if you're in the Arduino IDE, you have to pick that from the boards menu. Otherwise, you have to specify it on the command line. But that's the stuff that I had to do to get this to work at all. All right, back over here, the demo that I want to show is this color loop demo, which came with the thing. So here's the color loop demo from MakeBlock. This is from the MakeBlock libraries. We include this header, which gives us access to like where things are on the board and stuff. And then what they do is they have a setup thing. If you are a Ranger, that's this Ariga is the name of the control board for the Ranger. We want to say that our RGB LED thing, that's what we're doing, is we're going to blink lights. So we're blinking lights. We have to set up the blink of lights thing. This lights is our actuator for this robot example. Not the most exciting actuator, but it makes the robot not move, which is easier for demos where I'm working on my desk. So our setup is to make sure that we're setting the correct pin for our actuator. Then in loop, so Arduino programs are split up into setup, which runs once, and then loop, which runs repeatedly forever. And then loop calls color loop. Color loop does this stuff. It does LED set color at, and then LED show. And let me just run this and show you what it looks like. So I have a make file here. In my make file, if I type make, does Arduino CLI compile, which compiles this Arduino program. And then it does Arduino CLI upload, which is going to send this thing over USB to the robot. And let me hold the robot up. Robot is up. Oh, I need two hands to type. Let me type make. Then let me hold the robot up while I press enter. This robot is held up. This robot actually isn't even turned on because it's getting power for the Arduino board from USB. We'd have to turn it on in order to run the motors. But the motors aren't the actuator that I'm using. If I hit make, it's going to go ahead and compile and run. And then we get super bright, flashy lights. Oh, you can't see anything because it's super too bright. But that's what's going on. I'm going to put this down. Is there some way that I can make this a little bit better before I put it down? So if I just take a random piece of paper, Now, the freaking LED is still too bright for my camera, even through the piece of paper. But it's doing a color light show with the color LEDs over the top. Hopefully, you believe me. So the next thing that I want to do is make a slightly more complicated program where we're actually going to control the actuator from the computer. We're not just going to have a program control the actuator. Can we see the bright lights? No, not really. I'm not just going to control the actuator from the computer. We're going to have from the robot. We're going to have the computer send serial messages to try to control the actuator. So that's the serial example. So if I look at seriallight.ino, we're using the same actuator, this ME RGB LED. Get a couple of global variables, and one of the global variables is enable. If that's true, we will do something with the light. If it's not true, we won't. So we're going to go ahead and enable or set up our actuator to use the correct control pin. We're also going to initialize the serial library, and we're going to run a serial connection at 9600 baud. That's 9K per second, 9K bytes per second of data that we can send back and forth. So now in the loop, if there's a available serial data, we're going to go ahead and read a line from the serial port into our temp thing. And then we're going to print out back on the serial port what message we got, so we can see what it's doing. And then if that command that we got, the last command that we read from the serial port is the string on, then enable is true. Otherwise, if we got some other command, we're going to turn enable off. Then if enable is greater than 0, we're going to set one color to be, this is RGB, so we're going to set one thing to be green. Otherwise, we're going to set everything to be black. We only turn on one light at a time, so we get a spinny thing. We get a delay, so the spinny thing takes some time. So I'm going to go ahead and type make here. When you bring up this robot, I'm going to type make and then bring up the robot. Make. Then I'll bring up the robot. You can see it has this ridiculous bright light. I hit enter. It's going to send the new control program to the robot. And the ridiculous bright light turns off. And now we have one green light stuck. So let me run this off.sh script, which is going to send a serial command to the robot. So off.sh sends the message off as a single line. So that turned the light off. And then if I run on.sh, it's going to turn the light on. And we've got some bug with it lagging, but you can see that the light is now spinning, off, on. So we're not uploading a new program to the robot. We're communicating with the robot by serial. And rather than having well, let me show you what off and on actually do so that I can make this a little bit clearer. So off is going to call this script called light.rb. So this is a Ruby script that actually talks to the serial port, and it's going to pass in the string off. Then if I go look at tool light.rb, this thing connects to the serial port, and then is going to write text out to the serial port, write the text that we got in the first command line argument with the string off or the string on, and it's going to read one line of text back and print it. But there's no rule that says that our program running here on the computer only has to send one message. This thing could be an entire robot control program that used a protocol more complicated than off and on, and sent motor commands and flashy light commands and requested to read data from the sensors and then interacted with them in some way. And so through this mechanism of having a program running on the Arduino that is sort of acting like a driver or firmware layer between the stuff that we can do on the robot and the stuff that we want to, and like commands over the serial port, we can then have our control program be primarily on the computer, but communicate via serial to send commands to the actuators and read data from the sensors. So that's what I've got for now. I would like to do a demo where I have an Android app do this instead of a simple Ruby script, but that will probably be early next week if I get that done. So good luck getting started on the project, and I'll talk to you all later.